Something shifted under Yellowstone last July. Not metaphorically, literally. The ground on the north rim of the caldera, just south of Norris Geyser Basin, started moving upward. Slowly. About 2 centimeters over the course of the summer, roughly the width of your thumb. And then, in November, directly on top of that rising ground, over 200 earthquakes occurred in a matter of weeks. The largest swarm in that area in years. The USGS tracked every event. The University of Utah seismograph stations logged every tremor. And their official published statement, the one you won't see in the news headlines, was this: "At this point, there is no way of knowing what will come of this current deformation episode." That is a federal monitoring agency saying, in plain language, we are watching something we cannot yet explain. Most of the coverage you've seen about Yellowstone falls into one of 2 categories. Either it's pure panic, the supervolcano is waking up, run for your life, or it's pure dismissal. Scientists say there's nothing to worry about, move along. Neither of those gives you what you actually need, which is the real picture. What does it mean when the ground starts rising in a specific spot? What does a swarm of 200 earthquakes actually tell a seismologist? And what is the thing about Yellowstone that researchers quietly say is the real, underappreciated hazard? The one that doesn't require a supervolcano at all? There's one finding that came out of Yellowstone research this past year that I haven't seen covered anywhere in connection to this swarm. It was published in the journal Nature. It changes the conversation about what the actual danger looks like at Yellowstone right now. Not in 1,000 years, right now, with 4 million people visiting the park every year. I'll come back to that before we're done. If you're watching this channel for the first time, hit subscribe and drop a comment with where you're tuning in from, whether that's Wyoming, Montana, Idaho, or somewhere much further away wondering what it means for you if Yellowstone ever becomes more than a news story. I read every single one. Now, let's get into what's actually happening. The first thing you need to understand is what the phrase earthquake swarm means in scientific language versus what it sounds like in a headline. When most people hear swarm, they picture something building towards something catastrophic. The ground rumbling, the pressure mounting, the inevitable explosion. That's the intuitive reading. It's also not how seismologists use the term. According to the USGS Yellowstone Volcano Observatory, a swarm is simply a sequence of earthquakes occurring in roughly the same location in rapid succession. Not a single large shock followed by aftershocks, but a cluster of events without one clearly dominant earthquake. Yellowstone produces these constantly. In a typical year, somewhere between 1,500 and 2,500 earthquakes are located in the Yellowstone region. In 2021, there were 27 separate swarms. One swarm beneath Yellowstone Lake that year alone produced 825 individual earthquakes. You almost certainly never heard about any of them. Nobody was evacuated, nothing erupted. So when I tell you that the November 2025 swarm produced over 200 earthquakes, mostly clustered in a few weeks, with the largest reaching magnitude 2.7, you now have the context to understand what that means. It is elevated. It is above baseline. But it is not, by itself, a sign of an impending eruption. The reason seismologists are paying close attention to this particular swarm isn't the size of the earthquakes, it's where they happened. In July 2025, an area on the north rim of the Yellowstone caldera, just south of Norris Geyser Basin, began to lift. GPS stations installed across the park detected the movement. By the time the data was compiled, the ground had risen by about 2 centimeters, roughly the depth of a coin. That might sound insignificant. In geological terms, it is a signal. And when you know where it's been seen before, it becomes a much more specific kind of signal. The USGS gave this area a name: the Norris Uplift Anomaly. That name exists because this area went through a nearly identical episode between 1996 and 2004. For almost 8 years, the ground here lifted at rates that sometimes exceeded 15 centimeters per year, 6 inches, which the USGS notes was one of the fastest deformation rates ever recorded at Yellowstone. That episode eventually produced a magnitude 4.8 earthquake near Norris Geyser Basin on March 30, 2014. It was the largest earthquake at Yellowstone since 1975. Right after it struck, the ground that had been rising for years abruptly reversed and began to sink. Scientists interpreted the entire sequence as the accumulation and then release of pressurized hydrothermal fluids, superheated water and gas under enormous pressure, building in the rock, then breaking through. Now, the same area is moving again, and USGS geophysicist Michael Poland, the scientist in charge at the Yellowstone Volcano Observatory, published this in January 2026. At this point, there is no way of knowing what will come of this current deformation episode. He listed 3 possible outcomes. It could lead to more seismicity, it could lead to larger magnitude earthquakes, or it could culminate in the shallow accumulation of hydrothermal fluids, the same pattern as 1996 through 2004. What it will not do, he stated clearly, is lead to a volcanic eruption. But that third option, the hydrothermal accumulation, is where the conversation gets uncomfortable. In April 2025, a research team from Rice University, the University of Utah, the University of New Mexico, and the University of Texas at Dallas published a paper in the journal Nature. They had spent years working at Yellowstone at night, dragging a 53,000-pound vibrosace truck along park roads, the kind of equipment used for oil and gas exploration, generating tiny artificial earthquakes and recording how the waves reflected back from underground. Over 650 portable seismometers deployed across the park. All of it to answer one question that scientists had been debating for decades. How deep is the top of the magma reservoir? Previous estimates had ranged anywhere from 3 to 9 kilometers. A range that wide tells you how uncertain the picture was. The new paper sharpened that image dramatically. There is, according to lead researcher Brandon Schmont of Rice University, a sharp transition at approximately 3.8 kilometers depth beneath the northeastern part of the caldera. That's about 2.4 miles. Below that line, partially molten rock, pressurized gas, a volatile-rich cap. The system, as Schmont put it, hasn't shut down. It has been sitting there for a couple of million years, but it is still dynamic. Co-author Jamie Farrell, a University of Utah geologist and the chief seismologist at the USGS Yellowstone Volcano Observatory, explained why 3.8 kilometers matters specifically. At that depth, he said, we know exactly what pressures are involved and how gas bubbles behave as they try to escape. The good news is that current measurements show the gas is venting, slowly, steadily, through the cracks and channels in the rock, surfacing through the thousands of hydrothermal features that make Yellowstone look the way it does. The bubbles are rising. The system is breathing, as Schmont described it, like a pressure relief valve that lowers the chance of a catastrophic buildup. Here's what that picture looks like in full. Just 2.4 miles beneath the surface, a cap of partially molten rock and pressurized gas. The magma chamber itself spans roughly 55 miles by 30 miles, dropping to 10 miles deep. Below that, and this was discovered in 2015 by University of Utah seismologists, a second, deeper reservoir that is 4.4 times larger than the chamber above it. Hot rock that would fill the Grand Canyon 11 times over. a three-level system connected to a plume of heat rising from approximately 40 miles beneath the surface. And directly on top of this entire structure, a national park with 4 million visitors a year, boardwalks over boiling pools, geysers erupting on schedule, families walking the loops at Biscuit Basin. That's not a rhetorical flourish. Biscuit Basin is where you need to pay attention. On July 23, 2024, at approximately 10 in the morning, a hydrothermal explosion erupted from Black Diamond Pool in Biscuit Basin. This was not in some remote corner of the park. This was a popular boardwalk loop. Park visitors were present. The explosion sent debris flying hundreds of feet. The boardwalk was destroyed. A crater was left where people had been standing. Nobody was killed. The timing was fortunate. But the USGS described this event emphatically as demonstrating an underappreciated hazard at Yellowstone. This is what the Nature paper and the Norris Uplift Anomaly and the November 2025 earthquake swarm are all pointing toward when you hold them together. Not a supervolcano eruption. That's not what keeps Yellowstone scientists up at night. What they study, and what the ground deformation data is directly related to, is the behavior of pressurized hydrothermal fluids moving through rock in the shallow crust. The same fluids that, without warning, without any detectable precursor that would give you time to move, can tear open the ground beneath a boardwalk where families are taking photographs. Earlier, I told you there was a finding I hadn't seen connected to this swarm anywhere in the coverage. This is it. The Nature paper established that the top of the magma system is sharper, more clearly defined, more physically distinct than anyone had previously confirmed. That sharpness matters because of what it implies about the layer directly above it. The rock between 3.8 kilometers and the surface is what hosts the hydrothermal system. It's the plumbing. And the more precisely scientists can describe the bottom of that zone, where magma ends and superheated rock and gas begin, the more clearly they can model what happens when pressure builds in it. When the Norris Uplift Anomaly began rising in July 2025, and when over 200 earthquakes then clustered directly on top of that uplift in November, what scientists were watching was fluid movement through exactly that zone. Not magma. Pressurized water and gas, migrating through fractures, pushing the ground up, cracking the rock as it moved. FEMA's contingency planning for the Yellowstone region accounts for the simultaneous presence of more than 300,000 visitors and residents who would need to be moved in a regional emergency. The roads into and out of the park are limited. The window between a detectable precursor and an actual hydrothermal explosion, as the 2024 Biscuit Basin event demonstrated, can be very small. USGS monitoring has intensified. Seismic networks have been upgraded. New GPS stations were deployed in spring 2025, specifically to track the deformation near the uplift zone. None of that means an event is imminent. The USGS is explicit about that. What it means is that Yellowstone is not a static system that scientists have measured and filed away. It is a system that is actively changing, where the ground is rising in a specific spot that has behaved this way before, where a swarm of earthquakes aligned precisely with that rising ground over the fall and early winter, where the magma is sitting 2.4 miles beneath the surface in a condition researchers describe as still dynamic, and where 4 million people a year walk directly on top of it on wooden paths over pools that can boil a person alive. That's not catastrophism. That's the data. The last supervolcano eruption at Yellowstone was 640,000 years ago. The USGS puts the annual probability of another one at roughly 1 in 700,000. Nobody serious is suggesting it's coming soon. But the scientists monitoring Yellowstone right now are not watching for the supervolcano. They're watching the fluids. They're watching the ground move. They're watching the swarms align with the uplift and asking what the episode will resolve into this time. Michael Poland at the USGS said it will teach them new lessons about how Yellowstone works. That is a scientist telling you, carefully, that they are learning something they did not know. The most honest thing I can tell you about Yellowstone in the spring of 2026 is exactly what the monitoring agency responsible for it is telling you. The system is active, the episode is unresolved, and the most dangerous thing about it has nothing to do with a supervolcano. It has to do with what's in the ground between you and the magma, and whether the people standing on the boardwalk